Hello, students. I hope y'all are doing well. I miss being with you today, but hopefully this can get us through our notes together. This first part, we've been talking about areas of high pressure, how they want to move to areas of low pressure, and we'll talk more about that in this near pod. But I want you to go ahead and get to page 18, and we're going to fill this in. So the unequal heating of the Earth's surface is what creates all of these global winds that we're going to talk about today. The rising and the sinking of convection currents in each one of these different levels of the atmosphere is what causes these winds to bend. So we're going to talk about that. So I'm going to move on. So to start with, we've got areas of high pressure, I'm looking for my mouse, high pressure at the poles and low pressure near the equator, okay? Convection currents occur in each level of these altitudes, and that is what gives us our wind patterns, okay? All right, so the first thing I want you to see is we've got the high and the low again, and this is the equator on our globe. So these high pressures are wanting to move to low pressures, and from here, what happens is they're cooling off, and so then they tend to circle back and rise. So this is only one side, but it's over this whole area, a convection current here, and the same thing happens in the southern hemisphere, but it's opposite, okay? All right, and you don't have to worry about drawing these. I just want you to see how this works. And then in this area right here, we're going to talk about what these are in just a second. But it also, we've got this high pressure moving to a low pressure, and it begins to, right, heat back up, cool, rise. It continues in the southern hemisphere. It does the same thing, but it is opposite, okay? Because remember, everything it mirrors what happens in the northern hemisphere to the southern. Okay, so this is a pretty cool thing. From these two convection currents, they create this convection current, and this affects us. This is our weather. We'll talk more about that in just a second. So again, in the southern hemisphere, it mirrors. Okay, so these are the convection currents in these latitudes that make our wind and our different types of wind. So we're going to break those down right now. So the first thing we're going to talk about are trade winds. These occur between the 30 degrees and the equator right here. All right. Now, what happens is this wind is blowing down, and at the same time, our globe is spinning. So it does, with the Coriolis effect, it makes the winds curve. So they're blowing down. And the reason these are called trade winds, again, do you see that mirroring? Now be drawing this with your red coloring pencil on your page 19 on the back there. um, Lots of trade happened in this area where with Europe and Africa, South America, all of that happened within this area. So these were known as the trade winds because it helped carry their boats before we had motorized water vehicles and things like that. They had to rely on the wind. So that is the area called trade winds. Okay, moving on. This is that convection current that is creating that. Okay, again, this is coming down, cools off, rises again. This one rises and circles this way. Okay, all right. So the next type of wind that we're going to talk about are the polar easterlies. So these originate at the poles. Okay, all right. And so what happens is that, again, this wind is blowing down. And if we didn't have the Coriolis effect, it would just continue blowing straight. But because of the rotation of the Earth, that it makes the winds curve or bend. All right. Okay, so these are also called the polar easterlies. Now, wind is named from where it blows from. So this is blowing from the east. Okay, it's north and then east. It's going to the west, but because it's coming from the east, it is called an easterly. Okay, and they're from the poles, so they're polar easterlies. Okay, it bends from the east to the west. And color this in with your blue coloring pencil. All right, here's that convection current that's creating that there. Okay, so then we have something called westerlies. Okay, just based on that, we know that the wind is probably going to be blowing from the west. But let's look at that. Okay, this is the area where we live in this latitude right here. So remember earlier I talked to you about the convection current that was here, and it naturally created one here, and it does. And so that is what is creating this wind here. Okay, and it is blowing from the west, so it is called a westerly. The reason it's called prevailing westerly is it dominates this area. And this is a large area of where most people live. And so we really want to see what's happening in this area. When we look for our weather, this is the area that we look to. Okay. And so I don't know if you've ever noticed, but our wind, we're going to talk about it when we get to weather, but our weather when we look at forecasting, blows from the west to the east. Okay, so whatever happens in Texas, we usually get a day or two later because it's moving from the west to the east. Now that storm that they just had, it was moving towards us, but it hit a stream, a jet stream. We'll talk about that later, and it actually moved up, and we just got very little bits of it. So that was a blessing. So again, down here, same thing, it mirrors just like in the southern hemisphere. They're not really called prevailing westerlies. People don't pay much attention. Not that this area is not important, but not many people live in this area. Really, Australia, I believe, is the only continent really in this area. Not that Australia is not important, but the majority of the world relies on their weather from here. Okay, again, they blow from the west and bend to the east, and be sure and fill that in with your green coloring pencil. Here is that made, like naturally made convection current. Okay. All right. So this is known as the horse latitudes. And so basically this area right here, remember this is called the trade winds area right here. So they, because of the two different convection currents right here, this area there, the wind is very weak. Okay. So these areas come together and they circle opposite ways. And so there's not a lot of wind on that. And so it became known as the horse latitudes. So we had a lot of ships, right, that traded in this area, and they often carried livestock with them and lots of heavy cargo. So to help their ships get moving again, they tried to make them lighter. So they would throw things overboard. And unfortunately, oftentimes they threw their horses overboard to make their load lighter. So they would rather lose what they were going to trade with rather than lose their lives in the ocean, okay, at sea. All right, so moving on from there. Now, one last area is called the doldrums, and that is this area right here, okay, on the equator. So remember, we have our convection currents. One is going this way and it mirrors, and so it's going the opposite way. So we've got these two air masses coming together, and again, it's an area without any wind, okay? And so that is known as the doldrums. All right. Okay, so we've got the easterlies. This is just a quick review, polar easterlies. All right, then we have the prevailing westerlies. All right, then we have the trade winds here. Then we have the doldrums and we have the horse latitudes. Okay, all right, so that's, you can pause this again and make sure you have all this filled in on page 19. All right, and the last bit of page 19 is this, we've already talked a little bit about this, is the Coriolis effect. Basically, an object moves in a straight line, but because the Earth is spinning, it makes it curve or bend, okay? This is the reason our tropical storms rotate. Our spacecraft and airlines, they plan routes based on, and they have to account for the Coriolis effect. Okay, all right, so feel free to pause this if you need to, and we will go from there. Okay.